Hello and welcome to another video. In this one, we're going to be going over two different instances that are basically the same, but in completely different contexts, about why repr behaves a little strangely. And hopefully I'll convince you that it's not actually strange and that this is how Python just does stuff. But let's jump into it. Okay, so the first example comes from a previous video I did where I customized the exit built-in. It comes from the site module, so it's not exactly a built-in. To make it so if you just type exit without parentheses, that it just exits instead of being like, oh, you should have done Control D or exit pren. And the way I did that in the video was to type exit dot repr equals lambda exit. So then if you typed exit, it would, oops, I need to do lambda self. So then if you typed exit, it would exit rather than messing around. And I had to do this weird type exit thing. And and someone asked in the comments, why do you have to do that? That seems a little bit weird. Why can't you just do exit.repr equals lambda self exit? Why can't I just do that? You'll see that it doesn't take here. And the reason for this is repr is looked up on the class of an instance, not on the actual attributes of the object. So if we look at dict of exit, this will be oh, sorry, double under dict. What am I doing? If we looked at the double under dict of the exit built-in, you'll see that it has some attributes, including this repr function here. But if we look at the types dictionary, you'll see this is where the actual representation function is implemented, and that's what we have to override in order for it to happen. Now, the other situation that happened here, or happened recently, was there was a class which defined a repr, return C repr, and a subclass of that class. And a viewer of mine asked, why can't I just do return repr of super? Surely this should just call, double under repr, right? Repr is just the built-in, it's just a shorthand for calling double under repr. And if we try and run this, I fix the syntax. We run this and I do repr of D, you'll see that it gets this super class D object, which is totally not what we expected here. But this is actually the repr of the super proxy object itself. So this somewhat magical object here, which this is shorthand for, I don't even remember what it's shorthand for anymore because I don't use the non-shorthand anymore. I think it's this. Yeah, that produces the same thing. But what we're seeing here is the repr of the super object, and what we actually wanted to do is make sure that we're calling the repr of this object, and this will cause super to proxy this method lookup to the base class here. So if we do this now, repr of D will give us the C repr, which is what we expect there. And the reason for this is because, the same as the first problem, repr looks up the double under repr method on the class itself rather than the instance. So super can override this attribute lookup to do special things on the instance, but if we're calling repr, as we did here, well, the old code here, when we call repr here, it's calling super's implementation of repr. And I wanted to show you where that comes from in CPython, since I think showing you the actual magic that's happening here is important for learning. I happen to know that all of the built-ins in Python are in this special built-in module Python file. Normally modules show up inside the modules directory or in the lib directory. This is where pure Python files are. This is where C extensions are, well, C modules. But the built-in module is special. It lives in the Python, and then I don't know why this is spelled weird. I don't have the context there, but it's makes it a little bit annoying to find it. But in this module, we should be able to find built-in underscore repr. This is okay. Well, we'll have to search further. This is the built-in repr function, which just calls PyObjectRepr. If we do git grep, and Python uses a style where these will always be at the beginning of the line, so it can find it in here and look for, oops, PyObjectRepr, and this is the implementation of repr. Now, the actual important bit here is we are looking up TP repr, that's how it represents it at the C level. We're looking up repr on the type of the object and not the instance here. You'll see here, this is where it actually does the call here and a bunch of other stuff. You'll notice that stir is implemented similarly. There's a PyType TP stir. And this is kind of true for pretty much every special double ender method in CPython. It basically implements repr as something that looks like this. Repr O, and then TP equals type O, and then return TP dot repr O. So that's basically, you know, I put my repr here, and then we ran my repr on super, and let's just do my repr, something like that. Now we get both of them. Let's actually some little text in the middle there. On 3. So now if we call my repr on C, you'll see that it does this, and my repr on D, we get, you know, both the correct repr as well as the repr from super itself. And this is kind of how the code works. If we wanted to put it in one line, it would just be return type O dot repr. So it's like explicitly passing along this self parameter. So it looks like a normal method, but it's not. And from what I understand, this is for 2 reasons. One is performance. It's much cheaper to look up a attribute on the class itself because it is much less likely to have magical attribute lookup stuff. From meta classes are much less likely than get attribute implementations. But also it makes everything consistent. I remember change in Python 2.7 from Python 2.6 where the with statement used to look up the enter and exit attributes on the instance, and then it switched to using the class and had some extremely hacky fiddly code that needed to be adjusted for that. But anyway, that's how repr works. Hopefully, you know, showing you the C code was useful as well, and hopefully, you know, clears up those 2 oddities that we saw here. But anyway, hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one. Button. Why are you not working?